So in this case, we are looking for the value of A. We're looking for that final amount. And when we go to set this up, we see that we have the entire right-hand side. But we have a negative rate. Okay? Now, please use your common sense here. I have plenty of people today giving me answers that were above 45,000. I knew exactly what they'd done. They just hadn't made the rate negative. Think about this. Greenville's population is decreasing. So it doesn't make a lick of sense for you to give me an answer higher than 45,000 because that would be a population increase. So whenever we type this in, we should be expecting a decrease from our starting population. 45,000 is how many people we have. We are doing 0.123, negative 0.123 over 1. Close it off. Raise it to the 1 times 5 power. If you want to just put a 5 up there, that's fine. We hit enter. So, in that amount of time, 5 years, our population dropped down to 23,345.89246. And I gave you a little hint here. It says round to the nearest whole number because, guys, these are people. Okay? We don't cut people off at 0.89246 person. Just make it a whole number. So I'm looking at the 5 and I look behind it. Behind it is an 8. 8 means we bump the 5 up. So it's going to be 23,346. And I box in my answer so that it's easy for the grader to find. Number 5, Blairsville has a population of 5,000. Sounds like a starting amount to me. Got 5,700 people. Population is increasing at a rate of 7%. That's 0.07, kind of like our taxes. Okay? Not the increasing part, the fact that it's a rate of 7% for anyone that doesn't know. Sales tax. How many years will it take for the population to be 9,000? So I read how many years, and I immediately start thinking, okay, we need to find T. Well, population to be 5,000 means it's got to get to, or 9,000 means that's our final amount we want to know about. And of course, N is going to be 1. So when we write all this out, it looks like this. Again, positive rate because we're increasing again. And we don't know T. So what we want to know is when this entire left side equals this entire left side, right side. So I put them both in the calculator and I graph them to find out. I clear out whatever someone left in there for me. I've got 9,000 is my final goal. 5,700 is what I have now, but I'm adding to it at a rate of 0.07 over 1 raised to the 1 times t power. Well, I don't have t, so I use x. I'm just going to hit graph and see what happens. It might actually show up. I think it's going to be close. Oh, no. No, not at all. Nope, 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 nope. So now I regret this decision because I have to wait on my slow calculator. Okay? But this is why I tell you guys all the time. When in doubt, just start with a regular 10 by 10 graph. Okay? So just start with Zoom 6. And even though it's going to take it a minute, we kind of just let it do its thing, but we look and we see that no graphs are popping up, no graphs are popping up, no graphs are popping up. That's because we're starting at 5,700, which is, slightly higher than 10. So what we need to do is, whether it'll let us, we need to zoom 0, because zoom 0 is zoom fit. And whenever we do zoom fit, our calculator tries to fit everything on the calculator that it can, on the calculator screen that it can. Okay? So there's a horizontal line at 6,000. I want to know when our graph of 5,700 gets to it. Oh, it looks like it might do it. Is it going to do it in one try? Yeah, it's got it. So right there is when it's going to be crossing. So that's the intersection we are looking for. Second, calculate. Number 5 is an intersection. First curve, second curve. It's going to take 6.75 years. You could round that to 6.8. I probably wouldn't round that one up to 7. But again, a couple different answers that would work for it. 6.75. That's kind of a nice even thing to leave it at. but you could also expect to see it as 6.8 years. Either one of those would be fine.